sure we're recording this. So remember, with compound interest, you do have different compounding periods which affect what your interest basically earned will end up looking like. So I actually have a comparison table over here that I wanted to show with you. So remember, you have your annual compounding, which means the interest is calculated once a year. You can do interest calculation twice a year, so basically every 6 months, and that would be semi-annually. That means your end value would be 2. And then you have quarterly, which means every 3 months. So we have 4 quarters to a year. Every month, that would be 12 times a year. If we did interest calculations weekly, you would do it 52 times in a year. And then, of course, every day would be 365. So based on these different compounding periods, let's take a look at, how your interest is affected. Now, this is your compound interest formula. And then remember, for your simple interest, it's a linear formula because we don't have those exponents in our simple interest formula over here. And that's the reason why compound interest grows as fast as it does. It's because of that exponent that we have in the formula for a compound interest. So let's do some basic calculations over here. So I've just created this spreadsheet, and I can share it with you if you guys wanted to see what the calculation looks like. So I'll send the link for this spreadsheet through Zoom chat. So if you guys wanted to take a look at it or, use it for reference later on, you can. So we just started out with the basic premise that we have $1,000 that we want to deposit. So you will see that's the principal. Well, that doesn't work. I don't know. Let's try white. So that's going to be our principal over here. Your simple interest, we're just sticking with 5%, and we're going to be depositing the money for 5 years. So based on this, if we did a simple interest calculation, then we know simple interest stays the same year after year because your simple interest is always calculated on the original money you deposited, right? So it will always stay on the $1,000. So when you do a 5% interest calculation on $1,000, it comes out to be, $50. And you can see that calculation right over here. So basically, in this case, we took the interest formula, which you guys should be familiar with, I equals PRT. So we just took that formula to calculate our interest here. So 1,000 times 5%. And since we're doing this just for the first year, you will see that your time here was just 1, okay? So add that back into your principal, and at the end of the first year, we would have a balance of 1,050. You would repeat the same calculation for year 2, because again, you only calculate the interest on that original $1,000. But now at the end of year 2, you would have the $50 from year 1, and then the $50 interest you earned in year 2. So that would be your balance at the end of second year. And of course, you can continue with these calculations for all 5 years. So you will see our interest stays the same. We get $50 each year. And by the time you reach the end of year 5, you will have basically earned $250, right? 50 times 5 years would give us $250. So you can see when we break it down, for each year's calculation, you are basically earning $50 a year on the original $1,000. If you just put in the formula as it is, you will see that also gives us the same number, 1,250. And this is the formula you can see on the left-hand side. Oops, didn't mean to do that. A equals P times 1 plus RT in parentheses. Now, just to show you what happens if we do this calculation based on compound interest, and it's compounded once a year. So you will see we're using annual. So our end value is going to be 1, and that's what we are doing, calculating the compound interest, where you're just calculating the interest rate once a year. And I have actually added formulas over here on the right. I know you can't see that in my handout here, but if you just scroll, if you have a bigger screen, hopefully you can see it at the same time. So I've put the formulas for simple interest, compound interest, and we'll talk about continuous compounding later on, but all of those formulas are in here for you, so you can see that. So compound interest, guys, again, remember your formula is A equals P parentheses 1 plus R divided by N, and then the whole thing raised to the power of N times T. So N is your compounding period. And in this case, our compounding period is going to be 1 because we're just calculating the interest once a year. So the N value will be 1 in both of these, this example here. So first year, you will see is exactly the same as our simple interest. So you earned $50 in interest. Your balance at the end of the first year was $1,050. So same as compound interest in the first year, but that is where the similarities end, because now when you calculate interest for year 2, you are actually calculating from the previous year's balance. So your principal will actually change now for year 2, and your principal will become $1,050. So when you calculate your 5% interest rate on that, you will see instead of earning just $50 like we did with simple interest, you're going to earn $5,250. So now our balance at the end of year 2 is going to be, again, slightly larger than the balance at year 2 in simple interest. You had only $1,100 in simple interest. Here we'll have $1,102.50. So you can see how that changes. And again, as you keep moving forward to year 3, year 4, year 5, the previous year's balance becomes your principal. So if you click on these cells, you will see that, when I'm calculating the interest, I'm actually taking that previous year's balance as my principal and then multiplying it with my simple interest, the interest rate. And again, we're only doing this for 1 year, so you can put that in here. So at the end of year 3, you will now have 1,157.63 as your balance. Go to year 4, year 5. So look at that comparison. At the end of year 5, we had 1,250 in the simple interest account, but now here you have $1,276.28. So definitely a decent increase in our balance. Now, again, if you use this formula of A equals parentheses 1 plus R divided by N, and then the whole thing raised to NT, you will see you get the same amount, or you can use the built-in future value formula, and that's this guy right over here, FV. Then you put in your R divided by N, that's the first, so that's your rate of interest divided by how many compounding periods you have, which in this case was 1. Then your N times T, the exponent value, so that was 5 years times compounding once a year. 0 is because we're not making any kind of regular payments into this account, so that stays 0. And then, of course, the last value is where you put your principal, so the $1,000 that we started out with. So just use the built-in function. And remember how we were talking about this, the way these formulas are set up, they by default give you a negative answer, but that does not mean we have a negative balance. It just means that's how these spreadsheets calculate them. So this was just to show you with, N equals 1, but now if we change that, and that's kind of what's hiding behind this over here. Oh, he's not supposed to go up. Oh, well, we'll leave him where he is for now. So you can move that little black screen and you will basically see for the different compounding periods. Now, this first spreadsheet that you have over here breaks it down by each compounding period. So you will see if we did N equals 2, which means your interest is calculated twice a year. So every 6 months, you can see how at the end of the first 6 months, you would be at 1,025. But then when you got at the end of the first year, but second 6 months, you would be a little bit higher than what you had even in n=1 compounding period. You were at 1,050, but now here you would be at 1,050 and additional 63 cents at the year of end. Year 2, with compounding period 1, you had $1,102.50. But when you do semi-annually, that amount changes to $1,103.81. So if you just go through this first worksheet or spreadsheet, you will see how the money is growing because we broke it down. So you've got the semi-annual in column 3, the quarterly, n=4 in column 4 over here, monthly in the next column. I did not break down for the 52 weeks and the 365 days because, as you can imagine, that would be very tedious. So just using those numbers, I did what your balance would look like at the end of each of those 5 years. But up until monthly, for all the 5 years, you will see I have broken it down so that you could see how incrementally, but how that exponential growth is happening. So you can see that on the first spreadsheet. If you go to the second one, the second one here is a more concise one, and this was just to see how the comparison looks like over the different compounding periods. So again, on the left-hand side, you have your simple interest calculation. Then we go to compound interest, but that's n=1. So interest calculated once a year, n=2, twice a year or semi-annually, quarterly, monthly, and then you will see at the end you have the weekly and the daily. But then we also did continuous compounding, and you will notice there's a slight difference in balance as you go from year to year. Even if you just compare your compounding periods from 1 to 365, look at how the balance for each year is changing just a little bit. If you look at the end of 5 years, compounded once a year, we had $1,276.28. When we calculated our interest twice a year, semi-annually, that increases now to $1,280.08, so just a little bit more than the first time. If you are compounding it 4 times a year, so quarterly, again, your balance goes up to $1,282.04, so about $2 more than the previous one. If you're doing this monthly, you've got $1,283.36 as your balance. Doing it weekly, so once a week, you will see your balance is now here. You will see for monthly, we had a balance of $1,283.36. Weekly, our balance becomes $1,283.87. Now, when you go to daily, that $83.87 basically rounded up to 84. So that becomes your daily. And then when you go to continuously, it's again just a slight growth, right? You just went to $84.03. In some of these intermediate years, you will see the balance kind of stayed the same. So if you compare daily to continuously, in year 1, your balance stayed the same. Year 2, you basically saw a growth by 1 cent, so not a big difference. Same thing in year 3, you had an increment of 1 cent. Same thing in year 4, but then in year 5, you saw, of course, we had a little slight increase in our growth. Instead of 1 cent each, you went up to 3 cents. And, if you did this for more years, you would see the numbers growing. So continuously is this idea of where we're basically saying it's constantly calculating your principal. So it's even quicker than daily, but as you compare those last 2 columns, you will see they're very close to each other, right? So not a big difference between compounding your balance, your interest at a daily level or at continuous compounding. And you will see there's a slight difference between the formula between your compound interest formula and your continuous compounding formula over here. So just a way for you to kind of compare how all the different compounding periods look like and what your balance will be. But at some point, you are going to hit the maximum value that you can get and you wouldn't go any higher than that. So here's the future value formula that I used. So we'll look at some examples just to make sure you guys get comfortable using these built-in formulas. This was one of the examples we had looked at last time. And then this was also something we had looked at where they were just showing you over a period of 35 years, how big the difference can be in your balance. And we had talked about, you know, at the end of 35 years, in simple interest, you only had 9,300, so less than 10,000. But with compounding, and this was compounded monthly, you have $24,370.65 as your balance. So this one here is the simple interest growth in the purple, and then the pink is the compound interest. So you can see that's a big, you know, exponential growth. It's growing very quickly when it goes up and, you know, curves like that. But simple interest, you know, keeps growing at the same rate. So it's always going to stay, you know, a linear growth as opposed to your compound interest. Alrighty. So before we get into finding the principal, let's do a couple examples here. All right, let's do number 5, because that's asking us to do a comparison. So they are telling us, consider an investment of $20,000 with an annual interest rate of 5%. So part A is saying, if that investment is earning simple interest, how much will the investment be worth in 10 years time? And part B is saying, if the interest is getting, if the investment is getting annual compounding interest, how much will it be worth again, same period of time? So our principal, they're telling us, is $20,000. Our interest rate is 5%. Of course, we'll need to convert that to a decimal. Then for the simple interest, we don't have to worry about the end value. So they're telling us this is going to be over a time period of 10 years. For the compound interest, they're telling us it's an annually compounding interest. So that, of course, means your end value is going to be 1. So let's go ahead and do this, you know, with our spreadsheet. Again, if you guys want to just open up a Google Sheet, or you can also do this in Excel, you can do that. Or just open up, you know, Google Sheets. I think I'm just going to open up a new page on this one. So our principal is going to be $20,000, and let's make that into a dollar amount. This will be our rate, which will be a percent. So this should be 5%. Time, they told us, was 10 years, and we were compounding this once a year. So remember, for your simple interest, the formula is A equals P times 1 plus RT. Now you will need to use that because there is no built-in formula for simple interest in Excel. For compound interest, and I'm just going to write it out, is going to be 1 plus, then you do R divided by N, and then raise the parentheses part to N times T. So that's your compound interest formula. So let's see what we get for simple interest over here. Okay, Michael, I see your answer. Very nice. Let's go ahead and clear up all this writing here. So let's take a look. So just following the formula here, guys, you can do equal to, we have our principal of $20,000, multiply, and then in parentheses, we can say 1 plus R times our T value, which is 10. So you will notice I already pre-formatted my principal as a currency number. So you have the dollar symbol in there, and my rate as a percent. Now, if you don't format your cells, you would need to write this as a decimal answer then. So either you format this, and I just clicked on the percent to format it, but if you don't format it, guys, then you have to type in 0.05 for your rate of interest. So be very careful on how you use your spreadsheet to do the calculation. Now, if you were just going to throw this into a handheld calculator, then, of course, you would type in 20,000 parentheses 1 plus our rate of interest was 0.5, and you would be multiplying that by 10 years. So if you were going to put this in the calculator, you would type it in this way. So still, using that formula. So Terry, I'm guessing you just gave me the interest amount, right? The 10,000. Yeah. So just add it back into your principal and you would have the amount of how much you would have at the end of 10 years. So, that's a still decent amount of money we have at the end of 10 years, but let's see how that balance will change when we do it compound interest instead of simple interest. So if you were, again, just following the formula, guys, that would be, you start with your principal, then multiply it by 1 plus your R divided by N, close parentheses, and then we raise that to an exponent. And again, I'm just going to put this in parentheses of N times T, which is our 1 times 10. And you will see this gives you a little bit of a higher balance than just simple interest. And again, if you were going to throw this into a handheld calculator, again, you would do 20,000, 1 plus your interest rate of 0.5 divided by 1, and then raise it to an exponent of 1 times 10. Now, in this case, you would say, I'm just dividing by 1 and multiplying by 1, so I can skip that. And yes, you can. But the only thing is, if instead of 1, that was a different number, then, you would need to remember to include those. With 1, these guys are going to be the same. But, what if this guy was not a 1 and it was a different compounding period? So that's kind of the reason why I like to just put the division and multiplication in there. Okay, Michael, I'm not sure what that answer is that you're sharing with me.
I didn't mean to send that. That was an accident.
Oh, okay, no worries. So again, guys, a difference of $2,577.89 just between simple interest and compound interest. Now, if you change that compounding period, also, that balance is going to change for the second part. Now, just to show you how the built-in formula would work. So if we wanted to use the built-in formula, you would use the FV. And then over here, for the first part, you would take your rate divided by your compounding period. So that becomes the first part of the argument. Then comma, for the second one, you do N times T. So that's the second argument. And then for the third one, we by default use 0 because we're not making regular payments into the account. So keep that as 0. And then the final argument is going to be the principal. How much money are you investing? So get all those 4 arguments in there, hit enter, and you will see, again, the same future value as we got by using the formula over there. So this was just a comparison between using simple interest and compound interest. So this is your solution for, problem number 5. So let's come back over here and let's do something like, let's do number 8. So number 8 is talking about, suppose you obtain a $3,000 certificate of deposit with a 3% APR paid quarterly and it matures in 5 years. They are asking us what is the future value of the CD in 5 years, how much interest will you earn, and what percent of the balance is your interest. So let's see, the value of the CD is your principal, so that's $3,000. They're telling us the APR is 3%, so of course, as a decimal. Paid quarterly, so that tells you the interest is being calculated every 3 months, so 4 quarters in a year, and the maturity of the CD is going to be in 5 years' time. So they want us to find the future value, they want us to find the interest, and they want us to find what the percent of the balance as your interest become. So 3 things that we're trying to find. Okay, so let's come back over here to our spreadsheet, and let me clear these guys. Okay, so since we already have the formulas set up in there, instead of starting over, we can go ahead and change our dollar amount to $3,000. Our interest rate is 3% now, so we can go ahead and change that. We are doing this for 5 years, and now we are compounding this 4 times a year, so that becomes 4. And this guy will, of course, again, if you're not pre-formatting it, then you will need to rewrite your rate as 0.03. So just by using those cell references, you will see I didn't have to retype my formulas in there. It already did the calculation for us because, we did not type any numbers here. Every one of this was a cell reference. So that way we didn't have to go back and retype anything, and it changes automatically. And you'll see the same thing happened with that FV formula because we used the cell reference for all of them. We didn't have to go back and make any changes. And that's the reason why using a cell reference with spreadsheets makes your calculations a lot easier. So you can see we really did not need a simple interest calculation for this one. So this is not the number you are looking for. They wanted what our future value would be. So of course, our future value is coming out to be $3,483.55. Can you tell me how much interest did we earn? Because that was our next question. How much interest did this certificate of deposit earn over 5 years? Okay, Michael, very nice. I see your answer. So interest would basically be taking your future value, right? And subtracting the principal from it. So if you take your future value and subtract the principal from it, that will give you what your interest is going to be. And of course, since you started out with $3,000, you can see the interest will come out to be $483.55. Sarah, very nice. Yeah, perfect. And then they're asking you what percent of the balance is your interest going to be. So to find that percent, out of the balance, what the interest is, you are literally going to take your interest and divide it by your future value and, convert that into a percentage. And that would give you your percent. So that would be taking your 483.55 and dividing it by the total balance of $3,483.55. And again, if you convert that to a percent, it will give you, the percentage answer, 13.88. Because they are specifically telling us what percentage of the balance is the interest, right? So that's how you know you have to take the interest and divide with the balance. So questions on that one, guys? Everybody okay with that calculation? Okay. Okay, so let's see, we've done compounded annually, compounded monthly. Yeah, Terry, go ahead.
I'm still a little confused about when we're doing it on the spreadsheet, how we get the cells formatted. I did it earlier and it didn't work, and I don't know if what I'm doing is wrong. So,
Okay, which one are you getting wrong?
so earlier, the first one that you did, 2000. Can you show me again how you formatted the cells for that one?
Okay. Let's go ahead and clear our formatting. So we're just going to make it plain text for now. Okay. So we know this was supposed to be $3,000, or you can do
Okay.
the 20,000, right? So I just typed the number in and then I clicked on the dollar symbol here. So that would convert it to dollars. Then we had, oh, what was our interest rate on this guy?
It was it's 5%.
3.
3, sorry. Yeah. So if you type
Oh,
3
yeah.
in,
Second one.
I'm just doing the second one. Yeah, if you do
Okay.
the 3 in and click on the percent, it actually gives you 300, and that's incorrect. So I actually delete that, put the 3 again, and it fixes it. Because what it does is, if you don't have a formatting, and let's change this back into a plain number. So what happens is when you put 3 and you click on the percent, it actually multiplies it by 100. And that's where the 300 comes from. So all you need to do is delete that number and type the 3 again, and it fixes it. And
Okay.
then for the time, of course, we don't have to do any formatting, so you can leave that at 10. The N was quarterly, so we can leave that. Sorry, this was not 10 years, this was 5 years, wasn't it?
5.
Yeah, and that's all you do. So you just literally have to do the formatting for the dollar amount for the principal, and then the percentage for the rate.
Okay.
Yeah.
Okay.
And after you did the calculation here where they wanted to know what percentage your interest was in terms of the balance, I actually did the formatting after we calculated our value. So if you put that in plain text, again, by default, it's going to give you a decimal answer. And then once you click on the percent over here, it automatically converts it to 13.88.
Okay.
Yeah.
I think I understand a little bit better now. Thank you.
Yeah, no worries. Did anybody else have questions on this, guys? And just to know that we are calculating that as a percent. Okay, we were doing the weekly example. So yeah, let's take a look at this guy over here. So they're telling us we deposit 10,000 into an account that's earning 4% APR, which is compounded weekly. They want to know how much will we have in the account in 25 years, how much interest will we earn, and then this time they are asking us what percent of the balance is interest and what percent of the balance is principal. So they're having us do it for both the interest and the principal. So let's see, principal that we are starting out with is $10,000. We have an APR of 4%, which again, as a decimal is 0.04. We are compounding these weekly. So of course, that's 52 weeks in a year. And then time, they're telling us, is 25 years. And then they want to know what our account will look like in 25 years. So we are, of course, finding our future value. How much interest have we earned? And then what percent of the balance is the interest? And what percent of the balance is the principal? So that's what they're asking us to find. So we'll come back over here. And let's put in these new numbers. So now we are looking at a principal of 10,000. Did I get enough zeros in there? Interest rate of 4%. We're doing this for 25 years. and we are compounding this weekly, so that's 52 times in a year. So again, since we had pre-designed these and we use cell references, again, you will see as soon as we put those 4 values in, it automatically goes ahead and does all the calculation for us. So that way you can only change those 4 numbers over and over again, but none of these calculations will change on us. Now, we can easily identify our balance is going to be at the end of 25 years is going to be $27,172.37. Interest is the future value minus the principal. So you will see again that number has been calculated for us. So that comes out to be $17,172.37. And then what percent of the balance is your interest? As you can see, that's coming out to be 63.20%. And then the last question they actually asked us was what percentage of the balance is your principal? So that's going to be our principal. Divided by our future value. And again, you are going to be writing that as a percent. So same thing, this time we will take our principal, divide by our future value. And you will again see when you just do the division, it gives us a decimal answer, and then go over here and change that to a percent. And you will see this comes out to be 36.80%. Because you did earn a decent amount of balance, 17,000 something else, whereas our principal was only 10,000 something, or actually right at 10,000. So obviously the principal as a balance of your as a percentage of your balance has to be a smaller percentage than the interest, just because they are pretty far apart values. So question on this one here, guys. Okay, so what I want you guys to do is give you a chance to work on one example and see if you guys are able to do the calculation and come up with the answers on your own. So let's pick. Yeah, let's look at, well, we haven't talked about. Well, let's do number 14. We haven't talked about effective rate, but we'll do that in a minute. So at least go ahead and do part A and B. So this one is saying Braylon invests $1,200 in an account that earns 4.6% compounded quarterly, and Angad invests the same amount in an account that earns 4.55 APR compounded weekly. So you've got Braylon and Angad. Okay, so they're both investing the same amount. So that's going to be $1,200 for both of them, which of course is the principal. Let's see, Braylon has an interest rate of 4.6%, whereas Angad has 4.55%. Obviously convert those into decimals. And then let's see, for Braylon, the compounding period was quarterly. For Angad, it was weekly. What else did they tell us? APR, investment, quarterly, weekly. Okay, and then your time frame, of course, for parts A and B is going to be different. For part A, they're saying what the balances will be after 15 years. Part B says what will their balances be after 30 years. So let's see what you guys can come up with. So you should have 2 answers, one for Braylon, one for Angad. What are you trying to enter, Terry?
I'm still trying to format the spreadsheet and I can't get it to work.
Are you using just these symbols here on the top?
Well, I already have that part where it's, yeah, I have that part already done on the top. But what
So
I can't
which-
get is when you put the formulas in, like A equals P parentheses 1 plus RT.
Oh, this is
in
not the
parentheses, I
formula.
can't,
This was just what I put. The formula will just be this, what you have here. So what you would do in this case is you would start by okay, your percentage keeps rounding up. Oh, in that case, Sarah, you're going to have to use, and I'm not sure if you're on Excel or Google Sheets, but you will have to use this to increase your decimal places. Yeah, so it's probably set to 0 decimal places, and that's why it's rounding it up to just a whole number. So Terry, what you are doing is, and let's do this for the compound interest because that's what you're calculating here. What you would do in this case is start by typing in your equal to, then click on, if you're using this formula, the A equals, P times 1 plus R divided by N to the power of NT. If that's what you're using, start by typing in equal to, then click on the cell where you have your principal. So that would be, whatever the cell number is for you, B2 or, whatever it might be, A1, doesn't matter. Then you will use the asterisk for your multiplication. Then open parentheses. 1 plus. Now this is where you're typing in your interest rate divided by your compounding period. So the cell where you have your interest rate, click on that. Then divide it, use the / for that, divided by your compounding period. So what is your N value divided by that? So again, click on that cell where the N value is, which in my case happens to be B5. Close your parentheses. Then you will use the little caret symbol for exponent. And then open parentheses again. And this time we are typing in N times T. So click on the cell again where your N value is. And then asterisk for multiplication again. And then for the T, click on the cell where your T value is. And then close your parentheses after that.
okay, and you type that all in that bar that's up above.
Yeah, I mean, basically it's going in this cell over here, but it also shows up over here at the top.
Okay.
Yeah.
What are the original questions we're trying to answer?
So you are finding out what the balance is going to be in both Braylon and Angad's account at the end of 15 years and at the end of 30 years.
And they're both compound.
Yeah, so they just have
Okay.
different compounding periods. For Braylon, it's quarterly. For Angad, it's, weekly. But yeah, they're going to have compound interest for both, but just different compounding periods and different rate of interest, obviously, as you can see. So it's number 14 again that we're looking at here, guys. And if you want, I can also share this link with you for the textbook. And then just go down to where the exercises are at the bottom. So this is the link for the textbook. Okay, so we will need to put in all the new values. As you can see, I just did a copy paste from the first one and just repeated that calculation and just gave titles for Braylon and Angad at the top. And as soon as you put those 4 values in, the calculation will happen automatically because I left the cell references as they were. So the calculation should take care of itself. I shouldn't have to go back and, retype anything. So let me know once you have your answers for parts A and B for both the gentlemen in here. Okay, Michael, I see your answer. And as you can imagine, you're starting out with a relatively smaller balance, right? $1,200. So you should not see a huge, future value. It should still stay, I'd imagine, in that 4-figure area. So part A is after 15 years, what their balance is, and part B is after 30 years, what their balance is going to be. All right, Michael, very nice. Okay, Amanda, I see your answer. And as you can see, I haven't calculated the answer yet since I'm waiting on you guys. So I am not able to tell the answers you're sharing with me are accurate or not. I guess I can do this by hand while you guys are sharing your answers with me. Okay, Terry, I see your answer for Braylon, okay. Amanda, I see yours for Braylon as well, alrighty. Okay, so looking at that calculation that I just came up with. Michael, your answer looks good for Braylon at 15 years. So that means Amanda and Terry, you guys need to recheck your math for Braylon. Okay, so we did Braylon at 15 years. Let's see what his 30 years look like. $30 years. Okay, so Michael, your answers are looking fine to me. Amanda, Terry, you guys are off by a few dollars here or there.
Ah, sorry. Was that?
And remember, they do have, different interest rate and compounding periods. So that will make a huge difference on what both of their balances are going to be. Okay. For Angad, Terry, your 15-year looks good. And even the 30 years for Angad looks good. Okay, very nice. Oh, Amanda, okay, okay, got it. Okay. So yeah, Sabrina, it is the same format of the equation that given to us in the textbook. So the idea is you take your principal, you multiply it with the 1 plus your rate of interest, which is then divided by your compounding period, and then you raise it to your compounding period multiplied with your time. So basically in this case, and I'm just going to show you for Braylon here, you would do the 1200. And this is if you were typing it into your cell, and then you would have multiply, open parentheses, 1 plus R, which should be a decimal number, 6 divided by our compounding period of 4, and then you raise it to 4 times 15 or 30, depending on which part you are doing. And if you do that, you should get the final answer. But instead of actually typing in the numbers, we are going to click on the cells to get our answer. So I'm not sure where the error is happening. I'd actually have to look to see what you're typing in, because it's something about the way you're typing in that Google is not, or Excel, whichever program you're working on, is not recognizing. So let's see, again, this should be your 1200, which then you convert it to the dollar amount. Same thing for Angad. He is also using 1200 as his principal. Then the rate of interest for Braylon is 4.6%. And again, as a decimal, that should be 0.046. For Angad, his interest rate was 4.55. And again, as a decimal, should be 0.0455. Make sure you keep all 4 of those decimals if you guys are using the decimal answer instead of formatting. Let's see, for the time frame, of course, both of them are using 15 years. And then for Angad, the compounding was happening weekly, so that would be 52 for the end value. And for Braylon, the compounding was happening at quarterly, so that would be 4 for him. So as you can see, oh, okay, Sarah, yeah, I was wondering what happened. So Amanda, you're getting an error also. I would honestly have to see what you guys are typing in to know why you are getting an error. Now, here's the thing. With the way Excel works, or even Google Sheets, you do have to put this multiplication symbol here between the 1200 and the parentheses. If you just did 1200 and did open parentheses, they are not going to recognize that it means multiplication. So you do have to type in the little asterisk, and you can see that in this formula that I have over here. I did my principal of the 1200, then I am multiplying it, so I have the little asterisk there, and then I do the 1 plus R divided by N to get your the parentheses part then. So the 1 plus R divided by N, and again I just clicked on the cells where I had my rate of interest and my N value, close that parentheses, then you use a little caret symbol to show that you are now doing an exponent. And then again in parentheses, we type in N times T. And again, you can do this using, the cells instead of typing the numbers. Now, if you wanted to type the numbers in, you can do that also, guys. So let me show you that over here at the bottom. So if you just wanted to type the numbers in, like I have these written down here, you can do that also. So if you were typing in the numbers, you can do equal to. So you are taking the principal of 1200, then you multiply, open parentheses, we do 1 plus, then our rate of interest of 0.046, and I'm doing this for Braylon. Then you're dividing this by your compounding period, which is 4. Close your parentheses. then raise the exponent, so the caret symbol, open parentheses again. And here our compounding period is again quarterly, so 4. And we're doing this for 15 years, so times 15. Once you get to this, close your parentheses again, and that will give you the answer. Either send me a screenshot, guys, or we can talk about this after class, because I am not sure why that name is coming from. The only other thing is, are you putting the equal to symbol when you first start out, when you're typing in your formula? Do you have that very first equal to sign there? Because equal to, yes, that's exactly what you have to do, Amanda. You do have to put, Sabrina, same thing. You don't have a multiplication. Like I said, if you don't have the multiplication, Excel, Google don't know that you are multiplying the parentheses with the number in the front. So after that B1 cell, Sabrina, you have to have a multiplication symbol. So right over here, you will notice I also put a multiplication symbol right here. Multiplication symbol. For that matter, if you see the original cell I have in here, that also has a multiplication symbol right there. Without that, Excel is not going to recognize, or Google Sheets is not going to recognize you are doing multiplication there. Okay, so if you look at the answers for 15 years, you will see that for Braylon, okay, for Braylon, you are getting a balance of $2,383.06, whereas for Angad, we are getting a balance of $2,373.87. Now, if we repeat these calculations for the 30 years, and I'm actually just going to do another copy paste, so that way we don't have to repeat the whole calculation again. So doing a copy paste, now I can just change my year from 15 to 30 for both of them. And you will see we will end up with a new balance for these guys. So at 30 years, you have a little more than, or almost maybe the double. Amanda, do your percentages look like they are supposed to look, the 0.0455 and 0.046? I'm not sure where else the error, or the compounding, make sure you have 4 and 52 for them. I'm not sure where else the error could be happening. So here, looking at the balance, we have, this is the balance for 15 years, and then these numbers over here are going to be your balance for 30 years. Okay, okay. And so these should be the two answers that we are looking for over here, guys, for each of our, people who are investing. So like I said, almost double from 15 years to 30 years, which is kind of expected because your time is getting doubled, right? So it looks like it may help you guys to do a little more practice with the spreadsheets, just to get comfortable on, how to type the formulas in, how to get those. Now, even your textbook walks you through. If you look at the examples here, it shows you how you need to, type your answers in for your spreadsheet. So you can look at the formulas, the built-in formula, or if you are typing in your answer. Just make sure, this was actually for a calculator, but if you were typing this into a spreadsheet, just make sure there's an equal to in front of the number, and then there's a multiplication symbol between your dollar amount and the parentheses. You got to have those symbols in there for the spreadsheet to work. Okay, okay, Amanda, very good. Okay, good to know. So, yeah, these should be your two answers from 15 years and 30 years. Let me see if it will let me get both of these together. And of course, we did not need these calculations, the percentage of the interest with the balance, or the principal with the balance or interest. But since we had already typed those in, I left those calculations in there. But obviously for this specific example, we were only interested in those cells that we have marked with the orange. Questions on this example here, guys? So actually, if you compare the answers, his dollar amount for Angad is actually less than Braylon's, and in spite of him having a higher compounding period, but you can see his interest rate was only 4.55%, and he was compounding, or he was getting a weekly compounding. But in both instances, for 15 years and 30 years, you will see his dollar amount, the balance in his account, is less than what Braylon had. And that is because even though Braylon had a compounding of quarterly only, he still has, basically 0.5% more in his interest rate. And so as you can see, Braylon does end up with a higher balance in his account compared to Angad. So the last part of this question was actually asking us what is the effective rate. And we're not going to have time today to talk about this because this last example ended up taking too long for us. But the effective rate basically means if we were to convert this compound interest rate from a compound interest to a simple interest and compare the two, what would the two interest rates end up looking like? So you can see you have 4.6% compounded quarterly for Braylon and 4.55% compounded weekly for Angad. So, we cannot do a direct comparison because they're not the same interest rate. They don't have the same compounding period. So the effective rate basically takes them and converts them into a simple interest rate. So then you can do a comparison, and that's what effective rate is. So we'll have to come back and do part C in next class, and then compare and see which out of the two had a better interest rate. So I'm actually going to leave this problem as it is on the third sheet of this handout. And again, if you guys wanted to take a look at this, I shared the link with you in the Zoom chat, but I can share it again if you wanted to keep this so you can look at how to type those formulas in. So I'll share that link again through your Zoom chat. So you can, like I said, make a copy or add a shortcut or whatever you'd like to do, and then take a look at how to put those formulas in. You can do that also. So we'll pick up from here, guys. I was really hoping to finish 2.2 today. We're almost honestly done. We just have to talk about, instead of finding the future value, what if we wanted to find how much to deposit today, so that you can have, whatever balance you're looking for later on, how to do that, the compounding continuously, how that works. And then the last part was finding that effective rate that we were talking about. So we'll definitely need to finish this next time so that we can get into the last two sections of chapter 2 and get that taken care of. All right, guys, we'll stop right here for today, and then we'll pick up where we left off on Monday. So I am obviously going to say I don't think we'll be ready to take the exam on Wednesday, but again, let's see how our progress goes on Monday. And then we'll see what the exam day needs to be, probably next Friday, I'd imagine. So, okay, so those of you who wanted to ask me questions, please stay back and I'll be happy to answer them. And for the rest of you guys, have a wonderful weekend, and I will see you on Monday. So be careful, guys. Take care.
Thank you.
Thank you. And then Sabrina, I did see your screenshots.